the potential difference between the terminals of an electrical heater is 60 volt when it draws a current of 4 ampere from the source. What current will the heater draw if the potential difference is increased to 120 volt? So what they're asking is, just a second, I'll draw the circuit diagram. Need not draw for this, but I'm just drawing for the sake of explanation. So what they're telling is you have a voltage source. So if it's 60 volt and if you switch on, you have a current of 4 ampere through this. If you then switch on to 120 volt, what is the current through this? Okay, you can use two ways. Okay, no, you know what? You guys think about it, then I'll explain. Okay, there are two ways. The first way is find R, right? And then find the current through the second scenario. If not, since resistance is fixed for this particular setup, right? Resistance will not change. You can change the voltage and thus the current will change. But the heater will remain the same physical structure. So resistance will remain same for both the cases. So you can equate the LHS and RHS and you can solve it. I'll explain both so that you guys understand. I'm sure it's a bit confusing what I just said. So let me show you the first way. Okay, let me first way. Over here, right? Yeah, the first way is given. Voltage 1 is 60 volt while current happens to be, the current happens to be 4 ampere. Right? In voltage 2, it is given 120 volt and the current happens to be what? Right? So actually now the first way will start because given is same for both. So let me do this first way. From the first set of information, V1 is equal to I1 into R. R is R because again, it's not physically changing, right? So this is from Ohm's law. Don't think too much about subscript. It's okay, just write. It's a representation, but the formula will remain the same. Is it not? It represents the same voltage, current, and resistance. It's not changing anything. It's just a we have a subscript. So 60 is equal to 4 into R. So divide with 4 both sides. So R is equal to 15, right? 15 ohm. So and then you will substitute this in first way working. And we'll substitute in V2 is equal to I2 into R. So V2 is 120. I2 is this and distance is 15. So we divide with 15 both the sides. I2 happens to be, how much will it be? 80. Wait, what? Yeah, not 80, sorry, 8 ampere. Is it not? So that's it. So this is the first way. You found the distance. Since it's not changing, you can do this. The second way is a bit shorter. So I'm going to write as resistance of heater remains same. So we have R is equal to V by I, V1 by I1, which is equal to V2 by I2, and this 2 is from Ohm's law. Again, so this is a separate answer, remember. So we need to mention that we got this formula from Ohm's law. Since these two are the same, we have 60 by 4, which is equal to 120 by the unknown I2. Right? And so simple calculation. So 1s are 2s are I2 is equal to 8 ampere. 8 ampere. 8 into 4 is 16. 16 into 4 is 24. 24 into 1 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 is 24. Again, the calculation is like this: 1s are 2s are. You transpose this, I2 into 1 is I2, 4 into 2 is 8, right? So you got the same answer. Again, both are correct. It's left to you guys how you want to do it.